Hey everyone, welcome back, and today let's solve Leetcode problem 1829 titled Maximum XOR for each query, the daily Leetcode challenge problem for today. So we're given a sorted array nums of n non-negative integers and an integer maximum bit, right? And we want to perform the following query n times. Again, note, very important, that this is a sorted array. So we have to find a non-negative integer, k, that it's less than 2 to the power of the maximum bit integer, such that nums at index 0 XORed by nums at index 1, XORed by so on and so forth, up until nums at index length of nums minus 1, or the last index XORed by k, is maximized, and k is the answer to the ith query. We have to simply remove the last element from the current array nums for these operations, rather for these XOR operations. And we have to return an array answer, where answer at index I is the answer to the ith query. So in example 1, we have the input array nums to be 0, 1, 1, 3, and our maximum bit to be equal to 2. And we output an answer array of 0, 3, 2, 3. Why? Because the queries are going to be answered as follows. For our first query, we're going to have nums to be our original starting value of 0, 1, 1, 3, and our k is going to be 0, because 0 XOR by 1, XOR by 1, XOR by 3, XOR by 0 is equal to 3. And our second query is going to be nums at index 0, 1, 1, right? And our k is going to be 3, because 0 XOR by 1, XOR by 1, XOR by 3 is simply 3. And for our third query, we have nums to be now 0, 1, right, the values that I'm highlighting, and k is going to be 2, because 0 XORed by 1 XORed by 2 is simply 3. And finally, for our fourth query, we have nums to be an array of length 1, the first element, and it's going to be 0, and k is going to be 3, since 0 XORed by 3 is 3. In example 2, we have the input array nums to be 2, 3, 4, 7, and our maximum bit to be equal to 3 in this case. And so why do we output 5, 2, 6, 5? The queries are going to be answered in this sequential order. Our first array, or rather our first query, is going to be when our input array nums is 2, 3, 4, 7, and k is 5, since 2 XORed by 3, XORed by 4, XORed by 7, XORed by 5 is equal to 7. Our second query is going to be when our input array nums is 2, 3, 4, and k is going to be equal to 2, since 2 XORed by 3, XORed by 4, XORed by 2 is equal to 7. And our third query is going to be when nums is equal to 2, 3, and k is going to be equal to 6, because 2 XORed by 3 XORed by 6 is equal to 7. And now finally, our fourth query, nums, when it's simply equal to 2, the element 2 is going to be k equal to 5. Why? Because 2 XORed by 5 is equal to, again, 7, the maximum element. And so for that reason, we'd have 5, 2, 6, 5. And finally, in example 3, we have the input array nums to be the following, and our maximum bit to be equal to 3. And following these XOR operations, trying to maximize those values, we simply get an output array of 4, 3, 6, 4, 6, 7. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and to think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so a quick summary of this quick problem statement here. It's kind of lengthy, kind of just to summarize what it's really asking. What is this problem statement kind of telling us to do? It says, for each query, we simply want to find the maximum XOR that we can actually achieve using some elements from our input array nums up to that query index, right? And to solve this problem efficiently, we're actually going to be using the cumulative XOR technique, where, again, XOR, let me comment this out. XOR actually is going to stand for exclusive OR, right? Which is going to help us flip bits, and that's going to allow us to maximize the resulting binary string values efficiently. Okay, so how are we going to structure our algorithm here? Okay, so we're simply going to calculate a cumulative XOR up to each query index and XOR it with a given value. I'm going to call it maximum bit, right? In this case, that's our parameter. So yeah, that's why we're going to have it maximum bit. And why? Because that's going to help us achieve the maximum XOR values for each query. Okay, and the key idea is here. Is by XORing sequential elements, we will essentially effectively accumulate all XOR combinations up to each query, which is going to help calculate maximum XORs for each query optimally, right? So like I talked about before, we'll have a max XOR in this case, that's what I'll call it, to store the cumulative XOR of all the elements in our input array nums. Then we'll have a results to store the answer to each query as an array. And then we'll simply iterate through the queries in reverse to manage that cumulative XOR. So first we have to compute the cumulative XOR of all the elements in nums, right? And for each query, we have to calculate the maximum possible XOR within the maximum bit by XORing maxOR with 2 to the power of maximum bit minus 1, which is going to represent the highest possible number with all the maximum bits set to 1, right? And we simply have to store each result at that index our query in the results list in reverse order to match this actual problem requirements, right? So with that out of the way, let's just go ahead and dive straight into the code here. So I'm going to initialize my max XOR like I was talking about before, and this is going to be initialized to 0 because of course we haven't actually started reversing through the array yet. Why? What is this kind of going to do? It's simply going to store the cumulative XOR of all of the elements in our input array nums. And we simply do this by XORing each element of nums with the max XOR as we actually iterate through it. So now we can begin iterating through our input array nums and building up this max XOR variable. So I'm going to say for num in our input array nums, right, simply looping through all the different elements in our input array nums. We're going to max XOR, and in Python, the way this operation is going to work is it's going to have this kind of caret-looking symbol here, XORed equals the simple value of num, right? So we simply, again, have to XOR each number or value in our input array nums as we traverse through it with that max OR to actually maintain that cumulative XOR up to that current position, which is going to update the max XOR to include all of the input array, or rather all of the values in our input array nums up until this num index. And we're going to do this for all the elements in our input array nums. So once we're done traversing through our input array nums, now we have to initialize our max result. Okay, like we talked about before, and this is going to be, actually I'll put parentheses around it, it's going to be 1 bit shifted by the maximum bit, I think that's how you spell it, minus 1. Okay, what does this do? 1 kind of shifted by maximum bit is simply a left shift that creates a binary number with a 1 followed by the maximum bit zeros. For example, 1 by 3, let me actually comment this out here. 1 shifted by 3, okay, oops. 1 shifted by 3 for 3 bits would give us 1, 0, 0, 0, right, which is binary, or 8 in decimal, right? Let me also 8 in decimal, okay? And simply subtracting 1 from this value, as you can see right here, is going to give us a number with all of those maximum bits initially set to 1, right? And this is going to be our mask to get that maximum XOR value for each of our queries, right? Like we see in the problem statement right here to the left of our code. So once we do that, now we can actually initialize our results array. I could call it answer, doesn't really matter. And I'm going to simply initialize it to be, of course, an empty list, which is going to store each maximum XOR result for each query, for each index. And now we can actually iterate over our input array nums backwards. And in Python, it's pretty simple. For I in the range of the length of our input array nums minus 1, starting from the last index, right, length of nums minus 1, going up until -1 exclusive, or the 0th index inclusive, to the beginning of our input array, and decrementing by -1, or rather 1, each iteration, right? Now, this is why do we actually iterate backwards? It's going to allow us to match the expected output where queries are actually processed from the last to the first element in our input array nums. And in this iteration, we can add to our results. So results dot append in Python max XOR. Okay, and again, this is going to be ORed by the max result, right? We're simply we're essentially for each query, we're simply using the XOR operation max OR with the max result and adding that result to our results for that query, right? And XORing with the max result is going to help maximize the XOR by basically effectively flipping bits in the max XOR within the bit range that's specified by the max by the maximum bit, right here, that we define our max result with, bit shifting it in by 1 right here and subtracting 1 from that value. Okay, so once we do that, now after we actually added that element into our input array, or to our result rather, for that query or index, we can set maximum XOR and update it so or it equals nums at that index I, right? We simply have to update again this max XOR variable, XORing it with the current index, or rather element, because it's going to remove the influence, you could say, of nums at index I from our cumulative XOR for the next query, right? So we don't want to overcount, and effectively we simply have to return our results array. Why? Because it's simply going to now contain the maximum XOR values for each query or for each index in that correct sequential order. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. And as you can see, this is just about as efficient as you can get. So to kind of reiterate, what does this code do overall? First, we simply iterate through our input array nums to actually calculate a cumulative XOR, right? Simply ORing it by the current value num, as we define that max XOR on line 4, right? And that's going to allow us to answer every single query in reverse order. And by XORing, again, the max XOR with the max result, we can find the maximum XOR that can be achieved within that maximum bit range, right? As we defined max result, as you can see on line 7. And as we simply iterate or move through our input array, we have to progressively adjust the max XOR and update it to respond accordingly to each query, right? It has to respond accurately for each index, right? So for the runtime complexity here, this is going to be big O of n, or a linear time solution, where again n is the length of our input array nums. Why? Because it's really only a technically one-pass solution. We really only iterate over our input array nums really once, technically twice. We have 2 for loops, but it's not nested anyway. Technically it's big O of 2 times n, right? So theoretically, yes, the time complexity here would be equal to big O of 2 times n, but as we know in time and space complexities, we know that coefficients don't really matter in memory and space complexity here. We can simply remove this 2, and this would simplify to a linear time runtime complexity solution of big O of n. And for the memory complexity, this is also going to be, let me comment this out as well, memory. This is also going to be a big O of n solution. Why? Because we really only use our results list to actually store different elements to the output, which simply is going to have the same exact size as nums every single test case. And so this is also going to be a big O of n, or linear time memory complexity. So if you guys enjoyed this solution and there's something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.